Welcome back to Watershape University. This is Dave Peterson with another summer series about pressure gauges today. We'll talk about gauge products a little bit and the proper use of them and why investing in a really good gauge is probably a really good idea for you. All right, let's talk about the gauges really quick. First of all, you'll see that I've got 5 gauges here. I would say this is sort of the minimum set of gauges that you should probably have, and there's a reason why I would have each one of these. What you might also need is potentially one that goes higher than 60 psi, although most of you guys doing swimming pool work shouldn't be operating at pressures higher than that, so that's pretty high pressure. What I would say is that you might need multiple copies of some of these. Like you might need a pair of 0 to 30 psi's just because you may be comparing relative pressures across a filter, and maybe you've got 27 psi on the inlet side and 30 or 20 psi on the discharge side, so that would be a good gauge for that range. But here's what we have. First of all, a pure vacuum gauge, which reads from 0 to 30 inches of mercury. And this gauge, the needle, starts at the far end and actually goes down because this is pressure getting reversed or lowered, I should say, down to as much as 30 inches of mercury. And that's vacuum only. Now, if you don't know whether it's going to be vacuum or pressure, you might look at a gauge like this. This is a compound gauge. Notice the needle is somewhere in between the two endpoints. It actually measures up to 30 psi on the pressure side, but the needle can also go backwards down to 30 inches of mercury. The big difference between these two here is that this one has a full range from 0 to 30, meaning I can read down to less than 1/10 of an inch of mercury, whereas this one, only about 1/3 of the gauge is that range. So the relative distance between them is much smaller, so you don't get quite as much accuracy with this type of a gauge. But it is a good high quality stainless steel gauge with a good range. And then 0 to 15 for relatively low pressures, 0 to 30, and 0 to 60 psi. Notice this gauge is a little bit hard to read right now. That's because these are all glycerin filled. The glycerin really helps stabilize the needles in there and protect all of the inner workings of it. It stabilizes it because without that needle would really be bouncing around. As you're reading a pressure, the pressures aren't always perfect. There's little vibrations with the equipment and everything, and that gauge will be bouncing around the needle, and you'll have to decide, well, is it 28 or 30 psi, 28 or 30, and it's bouncing around, and you might just take the average and call it 29. But with a glycerin filled gauge, that needle is much more stable. It tends to just lock in on something with very little relative bouncing around. Now, the other thing about these gauges you might notice is that I've got this needle attached to it here. This needle allows me to plug this gauge in and out of various pieces of equipment. In other words, I don't have to thread this in to the different pieces of equipment and worry about the Teflon tape and all of that. I just put this on one time. I can pop it in, take my reading, pop it out. If I put one in, and if I put this one in, which is the gauge I would start with on the pressure side, if I don't know what my pressure is, put the biggest gauge on there. If it only reads 20 psi, pop it out and put in your 0 to 30 so that you get a more accurate reading, because now I can read down to less than a half a psi very easily, even more refined than that. So what does that needle go into? That needle goes into this little device here. You may have seen me talk about this in my fluid engineering class. We called these Pete's plugs. There's a company called the Peterson Equipment Company that makes these. No relation to me. I get no money for promoting these. This one, I'm not sure if this is by that particular company. This might be a little more generic. I got this from McMaster-Carr. In fact, all of these gauges and the needles and these devices were purchased from McMaster-Carr. And at the end of the video, we will give you that shopping list if you want to repeat what I've got here. The cool thing about these is the thread of this is actually the same size 1/4 inch thread that you would have on the bottom of the gauge. And that happens to be the same thread for most of the swimming pool pumps in our industry. So if you want to put this device in on the basket strainer side and then one on the volute side, you could just leave these in place. If you need to drain the pump out, that's a different story. You'd have to back it out, just like you would take out the plug that's already in there. The nice thing about this is that I can just take this cap off, and when I do, water does not come shooting out of this. There's a seal in there, actually like a triple seal, and it actually holds back the pressure without allowing any water to shoot out. This little cap is really just to protect that seal when it's not being used. But when it's being used, you just take the cap off, water is not shooting out, and then I can just take the gauge and just push it through the seals. And now you can see that the needle is now inside where the fluid is. In fact, there's a little hole right there. That's where the water would actually get inside to the diaphragm here that, of course, pushes the needle and gives you your reading. These gauges are very accurate, even when the needle is bouncing around a little bit. And then what I'd like to do is maybe show you the usefulness of having some high quality gauges. So with that, we will jump off of this and show you a little practical example. So what I want to do here is just show you where we would use this information from the pressure gauges. So you might see pump curves where we've got a curve that generally goes from the top left down to the bottom right. This left side is our pressure readings, usually in feet of head. So let's just call this 50 feet right here, 0 down at the bottom. The horizontal axis is your flow rate in gallons per minute, so 0 gallons per minute. And let's say this does 120 GPM at the max right there. So that's the performance at some specific pump speed. You might see other pump speeds that are lower than, say, 3450 RPM. And what we're using these gauges for is to take multiple readings at different speeds. And if we plotted on that curve these different speeds, what you should end up with is a parabolic curve that connects all of those dots. And that parabolic curve is what we call the system curve. And it represents the performance of the pump, or of the system rather, based on the length and diameter of the pipe, the flow rate that you're operating at, the number of fittings, the equipment that's installed, like pumps and filters and heaters, not pumps. The pump is actually what's generating all this. And then whatever speed your pump is running at, the intersection of that system curve and your pump curve is exactly where your pump is going to be operating. So if that was the speed we were at, then right here I might say, well, we are operating at 80 gallons per minute and I'll just say 40 feet of head. Now, one of the reasons that I have these nice gauges here is because we are sometimes troubleshooting problem pools out there. And if we're not starting with accurate numbers to begin with, then we won't have good numbers on our chart here. And I can give you an example of a project that we were working on recently where the builder was having some troubleshooting issues, and he was coming back to us with points on that he was measuring that were kind of all over the place. They didn't fall on a parabolic curve. And I said, well, there's just something wrong. You know, the gauges are wrong. And we knew the gauges were off by at least 3 PSI because when the system was off, just the static reading was off by 3 PSI. In reality, they could have each been off by more than 3, but the net difference was 3 PSI. Once we started using the better gauges, all of a sudden we started getting better numbers. There was some air in the system that was throwing some things off as well, but having good gauges really helped solve that. And we were able to use that information to not only figure out exactly where we were operating, but it also told us exactly what speed we needed to set the system at so that the heater worked all the time as needed, the UV system worked all the time, and the ozone system was always in range, working with its vacuum pressures and everything, no matter what the condition of the filter was. In other words, as the filter got dirtier, it was a variable speed pump, not variable flow. As the filter got dirtier, everything still ran within its range. We had a minimum flow rate of 40 GPM to keep the heater working, and we had some other, restrictions on the system. But we were able to show that everything we had engineered was exactly correct. It just really came down to using good gauges to do that with. So now that you know a little bit about gauges, it's time to go get yourself a set of these. And what I would say is if you are doing renovation work, you should absolutely go and spend about $300 for this whole kit. Get a nice little Pelican case with the foam, get it all set up in there. You can, buy 20 of these. These are only a few bucks, so you don't mind leaving these behind. And if you ever needed to come back to the project, you can just plug in your gauges and get those readings. And the reason this is so important for renovation work is that you need to find out accurate total dynamic head numbers before you start sizing new equipment and figuring out what the next step is in the evolution of that renovation project. So get yourself some gauges. Thanks for tuning in to Watershape University, and we'll see you soon.